let's take a more complicated example. Slightly more complicated. Let's choose a nonlinear function, but we'll choose a simple one. Y equals 2 plus x squared. And suppose I ask you to find the difference quotient, delta y over delta x. So just memorize this formula. The difference quotient is just this. It's f evaluated at x of 0 plus delta x minus f evaluated at x sub 0, all divided by delta x. By the way, some books, particularly math books, instead of using delta x, they use what? Do you remember? H. Okay, so if you like, you could, instead of using delta x, you could use h. Okay, but let's follow Chang because he uses a delta x here. Given this function, what is f evaluated at x sub 0? What is f evaluated at x sub 0 in this case? Exactly. Heather, it's 2 plus x sub 0 squared. Okay. And what is f evaluated at x sub 0 plus delta x? Heather, do you want to do that one too? Exactly. So it's just 2 plus x sub 0 plus delta x quantity squared. Okay. X sub 0 plus delta x quantity squared is just x sub 0 plus delta x times x sub 0 plus delta x. And multiplying this out, we get x sub 0 times x sub 0. That gives you the x sub 0 squared. Plus x sub 0 times this. Okay. Now we're finished with x sub 0. Let's move on to this. Delta x times this gives us delta x, x sub 0. Plus delta x times delta x gives us the delta x squared. And let me just put parentheses around this to indicate it's the change in x squared. Okay. Now these two terms are the same. Okay. These are just scalars, so the commutative law of multiplication holds. So these two things are the same. So this reduces to x sub 0 squared plus 2x0 delta x plus delta x squared. Okay. All right. So what is the difference quotient? The difference quotient is this. Substituting in for this term right here, we have this expression right here. Okay, so let's substitute that in. I'll put brackets here. 2 plus x sub 0 squared plus 2 x sub 0 delta x plus delta x squared. Okay. And I'm going to need more room, so I'm going to erase this. all of that is just f of x sub 0 plus delta x. That's all of this stuff right here. Minus f at x sub 0, which is just this. It is 2 plus x0 squared. Okay. All over delta x. Now let's simplify that numerator. Notice we got a 2 minus a 2 when we carry that minus sign through. And we also have x sub 0 squared minus x sub 0 squared when we carry that minus sign through. So then our numerator simplifies to 2x sub 0 delta x plus delta x squared divided by delta x. Notice both of these terms involve a delta x, so we can divide through. The delta x divides through evenly, and this just becomes 2x0 plus delta x. Okay. And that's as simple as we can make the difference quotient. So this is really our final answer. That is the value of the difference quotient. Okay. Notice the difference quotient is expressed as a function of x sub 0, the initial value of x, and delta x, the change in x. Okay. The difference quotient depends on both of these things, x0 and delta x.